Hello everyone, and before you unsubscribe, I want to let you know that this series on physics and other sciencey things is in addition to my gaming channel, and I am not changing the direction of the channel at all. Frankly, I just want a way to review for my physics midterm, and what better way than make a YouTube video and also get to keep my channel somewhat relevant. So, well, frankly, I don't know where to start, but maybe let's start with something that keeps the universe moving, and that itself is movement. Frankly, I could get into the movement of atoms and particles, but frankly, I'm not there either. Obviously, to move something, something needs to act upon that something else to move it. A well-known physicist had the brilliant idea of saying, an object at rest will stay at rest, which, yes, I know is a mind-blowing concept. Now that we know what makes things move, we can start to develop some rules on how the things move in frictionless environments. The best way to look at this is to imagine an object moving at a constant speed, meaning that it will travel the same distance per interval, like me at my computer. Here we can begin to look at some graphs. Now, to start off, it's best to look at a graph that is positioned over time, which shows where the object is going in regards to x. Now from here we can actually figure out how fast the object is going from start to finish by taking the distance traveled and dividing it by the end time minus the start time. Yourself and know anything about calculus, you would know that that would yield the same slope as a derivative would. Now, if you were to do the same process again, you could also know how much the velocity changed over the interval. However, in our case, there is no velocity change, aka acceleration. Now, I may have just dumped a lot of info and a bit of math that may not make sense to you. Well, it's about to get a lot worse. So think about driving and the speed your car travels at. It's definitely not constant motion, especially in a fucking city. But then how do you find the speed at one instant? Well, it's really difficult to do manually, and I certainly hope you know calculus. Well, frankly, to find the instantaneous velocity, or speed, at one point you need to know the equation of the position over time graph. And then you can take that equation and take the derivative and then plug in the time you want to know how fast you are going at that one instant. Also, I apologize because if you don't know calculus, that probably didn't make any fucking sense to you. But essentially what a derivative does is find the slope of a line at all points, which just happens to be the velocity. So if you don't know how to do derivatives, you can find the slope at that one point by finding the slope between 2 points around it as close as you can get. You can't find a slope at a single point. Just like a single person can't find love. Now, I know I dumped a lot of info on you, and if you have any questions, feel free to ask them down in the comments, and I probably won't be able to answer them. No, but seriously, if you have any feedback or if I said something that's not accurate, please let me know. Also, don't forget to subscribe, as I will certainly be making more of these, because I need to review for my own midterms and finals coming up, and that's kind of the whole point of this series, actually, so fuck you. But anyways, take care, guys.